Let's take a quick look at applications. In this section, I'm going to help you set up equations, but I'm not going to take them to solution. Your previous section on how to solve simultaneous equations or systems, I'll depend on you to be able to do that. The main thing here is to be able to write the two equations. So the thing with applications here, and you can read this, but the first point, understand the problem seems kind of silly, but you can't solve a problem unless you understand it. So you've got to be comfortable with looking at the problem and recognizing kind of the way that we solve them. Slight differences in a few of the problems. Um, Important to define the variables, right? Because there's going to be two variables and two equations that you have to write. So you do need to represent them. And then you want to use meaningful variable names where possible so that you know what you're actually solving for. And then you're going to have to do the translation. You're going to be writing two equations for every one of these problems. So you got to pull out the two equations. And then once you have the equations, solve it, make sure the solution makes sense, and you can always check your answer, plug in the values back in and see that they actually work. Okay, so let's take a look at a couple examples. Probably the easiest are these direct translations, right? The sum of two numbers is 5. So right there you have an equation, right? You have two numbers, and it doesn't matter what you call them. There's nothing special, so I'll just call them x and y. It says the sum is 5. So if I add them up, it's 5. And then it says one number is 23 less than the other. Well, there's a couple ways you could do the second one. Well, if I said x and y equal to each other, we know that's not true. So one is 23 less than the other. So I could say, okay, that the x and the y relationship could be like this, that y is the bigger number. If I take 23 away from it, then it would be equal to x. Or you might have alternatively said that x plus 23 is equal to y. So the only thing you've changed is which are you calling the bigger number and which are you calling the larger number or the smaller number. And so either way, both are correct. They're both going to lead you to the same answer. So let's just stick to this. So here is your system of equations right here if you choose these two. And you can see this is an easy substitution. I'll replace x with y minus 23 and you get the answers. And the answers you get it'll be 14 and a negative 9 if you want to go ahead and complete it. Okay, so similar here. Dwight is 4 years older than his sister Maria. The sum of their ages is 46. Find their ages. Well, if Dwight is D and M is Maria, and it says the sum of their ages is 46. Okay, so that's easy enough. And then it says Dwight is 4 years older than Maria. So if I say Dwight is equal to Maria, that's not true. For them to be equal, Dwight is older, so I need to add 4 years to Maria. Or, and again, it doesn't matter. If I put Dwight is equal to Maria and I want them to be equal, I could take away 4 years from Dwight to equal Maria. You can see this is just algebraic manipulation. If I subtracted 4 from both sides, it would come over here. So these are both correct. You're just going to come at it from a slightly different way, but you're going to get the same answers. So if this is your system, then you can see this is going to again be an easy substitution into the problem. And if you work it, you're going to get Maria is 21 and Dwight is going to be 25. Okay, you can see they add to 46 and they differ by 4. The next two problems are similar, so I'm just going to do the first one, number 3 here, set it up, and the other one is similar. So if you read this, okay, two different jobs, right? You're offered two different sales jobs. The first company offers a straight commission of 6% of sales. The second company offers a salary of $390 per week plus 1% of sales. how much would you have to sell in a week in order for the straight commission to be at least as good? Now, so what are my two equations? Well, if P is your pay and S is sales, then the commission job, your pay, your P, is going to be 0.66% of the amount that you sell. And so we'll make that S. And again, this is an S, not a 5. Okay, so there's the pay for the commission job. The pay for the other job that has the base salary would be what? It would be you're going to get $390 a week, no matter what you sell, and then you're going to get a commission of 1% of your sales. And again, that's your S. And so the question is, okay, when basically do these two equal each other, such that you can determine what value would one be better than the other. So in order to find the break-even point of this, you have to set them equal. Well, this is a real simple substitution. Since I want to set the pays equal to each other, I can replace the pay here with what it is in the first job. And so 6% sales commission job, when does it equal the pay of the base and commission job? You go ahead and do the substitution, and then you solve that problem. And when you do, you're going to find out that the amount that you have to sell to break even is going to be $7,800. Okay, and so anything more than $7,800 would make the straight commission job better. Okay. The cell phone plan is similar. Let's go down to the tickets, coin. I'll just do the ticket problem. Coin problem is similar. Okay, the key thing here is you got to keep like things together. For example, tickets plus tickets will equal a total number of tickets. The amount of money plus the amount of money will equal a total amount of money. You cannot mix quantities of tickets with amounts of money. Okay, so if you read this, admission fee at amusement park is $1.50 for children and $4 for adults. Obviously, this is before inflation. On a certain day, 266 people entered the park, and the admission fees collected totaled $774. How many children, how many adults entered? Okay, well, there's two equations here. Well, if 266 people entered the park, they could only be adults or children, so you go fine. So the number of children plus the number of adults is 266. This is people plus people equals people. Now, what about the amount of money created? Well, if we charge $1.50 per child, then the amount of money collected from children's tickets is 1.5 times the number of children. Well, how much money is collected for adults? Well, it's going to be $4 times the number of adult tickets sold. And they tell us that when you add that money together, it's going to total $774. So there's your two equations. And it would be probably easy to just do a substitution by solving for C or A and then substituting in to get your answer. And so when you solve this, you're going to get the number of children is 116 and the number of adults was 266, right? And if you add those up, well, no, the adults, that totals 266. I'm sorry. The adults was 150. Okay. So if you work it out, that's what you'll get, and that totals 266. Okay, we're back to the old boat in the river. These are slightly different than the problems we solved before. I won't get into the differences. But in this section, again, you have to understand that a distance is equal to your rate times your time. And again, they talk about upstream and downstream. And so when you talk about a rate, your overall, how quickly you are moving, it's a combination of your speed through the water plus the current. So understand that your downstream rate is your speed that the boat is moving through the water plus the speed of the water added together. So that would be your rate. Going downstream, upstream, it's still the same speed through the water, but the current is working against you, so your overall rate would be minus that current. Okay, so if you write the two equations based on what we have here, it says that you go 36 miles, which is a distance, is equal to what rate? Well, if we're talking about downstream, it's going to be the speed plus the current time. It took 3 hours. And then they describe upstream. Okay, so this was downstream, this would be upstream, same 36 miles, but your rate is different because the current is now working against you, and it took 9 hours. So here you have two equations based on the information provided. Well, if I distribute the 3 and I distribute the 9, I get these two equations, which in this setup it would be relatively easy to eliminate by the addition method. And so again, this is a plus. So I could easily eliminate the current, because I got a plus and a minus, by multiplying that equation by 3 and then eliminating. And when you do that, you're going to get an answer that your speed is going to be 8 and your current is going to be 4. Okay, so a little bit different. These are actually, I think, easier than the ones that we did before. Again, take a look at where that rate comes from. Otherwise, I think it's pretty self-explanatory. Geometry problem here with just a rectangle. They're talking about the perimeter of a rectangle. So the formula for the perimeter is 2 times the length plus 2 times the width. And so they tell us that the perimeter of the rectangle is 48. So there's an equation. 48 is equal to 2 times the length plus 2 times the width. Then they describe the length with the width. So the length, it just literally translates length is or equals 6 more than 6 plus 2 times the width. So here's your second equation with an L and a W. You can see this would be real easy to do a substitution. You could just replace length with 6 plus 2W, and when you solve it, you're going to end up with a width of 6 and a length of 18. Next is an investment problem. Just a couple things to be aware of that I'll talk about. So when you read this problem, you see Lloyd has $590,000 he wants to invest, and he's going to split the investment between CDs that pay 2.5% and bonds that pay 4.5%. And he needs $21,000 a year of interest to live on. So how much should he invest in each account to make enough interest? So, two equations, right? Well, we got C for CDs and B for bonds. And right off the bat, it says that he has $590,000 to invest. So there's an equation because he's only investing in two things. So if you take the amount of money, the quantity of CDs and the quantity of bonds, it's going to total $590,000. Okay, a quantity plus a quantity equals a quantity. Now let's take a look at the interest. Okay, so this is a quantity. Now we've got to determine how much interest gets generated. Well, the amount of interest generated by the CD is 2.5% times the amount of money in the CD. Well, remember with percentages, we'd have to change it to a decimal. So if we multiply 0.025, which is 2.5%, times the amount in the CD, and we take 4.5% or 0.045 and multiply that by the amount in the bond fund, that's a B, then it should total $21,000 of interest, because this is all interest, right? So this is the interest generated from CDs, this is the interest generated from bonds, and together they will add up to 21,000. So interest plus interest equals interest. Quantity plus quantity equals quantity. Here's my two equations. This would be an easy substitution. I can solve the first equation for C or B and then substitute into the other. And when you're done, you'll get an answer of a bond. The bond fund was $312,000, and the CD account was $278,000. Okay, so this part shouldn't be hard once you have the two equations written. Okay, we're going to look at mixture problems. These are slightly more complicated, common in chemistry and other classes. So let's look at a couple of these. The first one, the thing again to understand is that the two equations, you got to keep things straight. You're going to have a quantity equation, the amount of in this case, candy of each type in terms of pounds, and then there's the value equation, the cost. Okay, so when you read this first sentence, Carson wants to make 20 pounds of trail mix using nuts and chocolate chips. So if we call N nuts and C for the chocolate chips, we can see that that first sentence yields us an equation. The quantity of the nuts plus the quantity of the chips is going to total 20 pounds. Pounds plus pounds equals pounds. Now let's take a look at the value. So they want to mix these together, and so his budget requires that the trail mix cost him $7.60 a pound. I'll get back to that. The nuts cost $9 per pound, and the chocolate chips are $2 per pound. And when he mixes these quantities together, he wants the value to be $7.60 each. So the question is, how many pounds of nuts, how many pounds of chocolate chips should he use? Okay, so now we're going to look at the value, right? So the nuts are $9 a pound, so the total cost of the nuts is $9 times the however many pounds of nuts you have, because N is the number of pounds. The chips are cheaper, they're just $2, so $2 times the number of pounds of chips. So this is a dollar amount and a dollar amount, and we want it to equal sum total. Well, we know that if you look over here, that we want the cost of the mix to be $7.60, and we know it's going to be 20 pounds of it. So if we multiply that, then we know that the total cost of this mixture is $152. So this is the tricky part, is you can compute your total cost here. So again, my pounds add up to 20, the values are going to add up to 152. Okay, so there's my two equations. Now you solve them. I would probably do a substitution. I'd solve this for N or C and then do the substitution in. And when you do that, the quantity of nuts is going to be 16 pounds, and the quantity of chips is going to be 4 pounds. Okay, one last problem from your chemistry class. The chemist wants to make 100 liters of a 52% acid solution. Okay, and you can see that there's two acids going to be mixed, a 20% and a 60%. So this first sentence gives us a quantity equation. We're making 100 liters and there's only two types of acid. So since they're both acids, I'll call A the 20% acid and B the 60% acid. And it says that, hey, if I'm making 100 pounds of these two acids, if I add the two together, I'm going to get 100 quantity. And the second equation has to involve the mixture, right? So you're making a 20% acid solution of A. Okay, so the quantity, or I'll just do the 20%, so 0.2 times the quantity of the A acid is the mixture, 20% of A. The mixture for B, it's a 60%, so 60% times the quantity of B gives me, and I know both the quantity and the mixture, the percentage of my final product. It's going to be 52%, and it's going to contain 100 liters. So this is fully known, just like in the other one that we knew the total cost of the mixture of the nuts, the 100 pounds of nuts and chocolates. Okay. So if you kind of clean this up just a little bit, you're going to see that this is going to be equal to 52 right here. So again, you have a very simple solution um, to get this because you have a plus b is 100. So this would be easy to solve for a or b and then do a substitution into the second equation and solve it. Again, this is equal to 52. This is a known end state, right? So at the end, you're going to have 80 liters of the B acid and the A acid. You're going to have 20 liters. Okay. Again, the setup is where all the work is. You should be comfortable being able to finish these equations. Okay. So that's it. That's the end of the applications.